In September 2021, Nokia launched the latest iteration of its FP series of routing processors, the FP5. And to find out more about this new data networking engine, I'm talking with Vach Kompella, VP and General Manager at Nokia's IP Networks division. So Vach, thanks very much for joining us today. Now, when Nokia launched the FP5 networking silicon, it was under the slogan, Master the Unexpected. What are the unexpected events that Nokia had in mind?
Well, Ray, I don't think we'll ever get a handle on the big I internet. And so we'll never be able to expect what's coming next. And I don't have a crystal ball also. But the past 18 to 20 months, we've actually seen a series of unexpected events that have changed so much about what we do that I think we need to sort of sit down and rethink how we build systems and how we build networks. So, for example, COVID changed everything that we do about everything, whether it's working, whether it's school, socializing, shopping, banking, everything was changed. And the amount of traffic that we saw over the past 12 months has increased almost 60%, which is far more than what we expected. So all these things are unexpected events, right? And the way that we want to sort of look at this is to say, do we understand what happened? Do we know how to deal with this? And then on top of that, with the sort of tremendous reliance we have on networks, we see sort of the unsavory side of things where we see security attacks, ransomware, people trying to steal confidential information. So what we want to do is to sort of rethink the foundations of how we build, for these networks that are so important now in our lives. And this new foundation that we're talking about has to have the properties of extensibility, agility, and security. And we think of it as three major pillars: silicon, systems, and software. And then we wrap all of this around with automation and analytics that allows us to basically really address what we think is the next unexpected thing without having to retool everything, without having to build new systems. So that's kind of how we're looking at this. And FP5 is a great launching point for us into this new world of the unexpected that we want to be able to master.
Can you tell us more about that? I mean, how does the foundation help operators to prepare for whatever they might have to deal with? Maybe you could start with the software.
Okay, so software, we have a single line of software that covers all of our routers. There are over 1 million routers that we've deployed across all networks around the world. And starting from low-end CPE routers to the core of the network, it's one software line. What this helps us to do is to be able to consistently manage, automate, operate all these routers. And it's really important, I think, for us to be able to present that to the operators so that they can deliver their services to the on networks without having to go through errors in configuration. And so for that, we want to bring automation into the picture. And automation is something that we really have to build into the system right from the ground up. And that's something that we've been very, very careful to do. But then as we develop the architecture for our software, we have to look at new techniques like microservices, which allows us to bring in new functionality and upgrade systems without downtime. And I think that's another important aspect of our software. And finally, I think the way we even do our R&D processes have to change dramatically to address this new world of the unexpected, where we have to deliver new functions very quickly, and we have to not compromise on quality. So we have actually been tooling our automation environment, which we've had for the past 20 years, so that we can actually data mine and find out where where we find more issues, where we have to put more resources. And even when we change a certain line of code somewhere, what are the tests that we have to run in order to deliver the quality that we need? So there's a lot of machine intelligence that's going into our testing processes and into our R&D processes also. So I think this is why we believe software is a fundamental aspect of how we are retooling ourselves for the unexpected.
Now, another important part of the foundation is the automation and analytics, which you already referenced there. What's your approach to this, particularly to complex changes to the network that have to be made by human beings and can't necessarily be fully automated?
That's right, Ray. There's new services and new functions that we want to introduce, and humans are the ones that come up with these new ideas. But once we have these new ideas, how do we actually deploy them in a network? See, machines are very good at being instructed in what to do. And so we take these new ideas and we want to be able to describe them in such a way that we can compile them into low-level instruction code, the same way we do with compilers. And this code that we now deliver to the network is configuration and monitoring and so on that allows the network to deliver these new services. And when we use automation, what we do is we take the human ideas and we translate them into these configurations that get pushed out. And that's essentially what we call code for the network. And that's the idea of how we use automation to deliver new services.
And can you tell us more as well about the silicon and the systems? How does the FP5 help customers to master the unexpected? And for those customers, does this represent an evolution or a revolution in their capabilities?
Well, Ray, can you do evolution and revolution at the same time? I think that's what we're trying to do here. So, first of all, FP5 is brilliant and has so many capabilities. And we build new systems, new line cards with FP5. But, the sheer unsustainability of saying every time we come up with something new, you have to rip out your whole network and put in something, that's better than before, is meaningless. We have to really address the fact that you have to evolve your network so as not to cause outages, disruptions, and so on to network services. But you have to also have a way to bring in these new capabilities. So I think what we're trying to do here with FP5 is, in itself, it's a revolution, but in the way it's introduced into the network, it's an evolution. An FP5 line card fits into the same chassis in which you have FP4 line cards. But there's a lot more behind that simple statement than just what I said. Because, for example, we're power hungry because we want more and more bandwidth. So what do we do about that? Well, we really have to come up with revolutionary new ways of designing our chips such that we can address that hunger for more bandwidth that will consume more power also. But the way we did FP5, you're using a quarter of the same power that you would have used before with FP4 for a gigabit per second of throughput. So while we're getting you faster and faster systems, we're doing it with lower power. And this is not simply the chip itself, but it's the whole line card. It's the chassis. It's everything that goes into the network, so that when you make a simple statement like, for the same power consumption, I can triple your network capacity or something like that. What it's telling the operator, the service provider, is you don't have to rethink the space, the power, the cooling. You don't have to put in a new transformer, a new power supply unit, nothing. You slide out your FP4 cards, you slide in your FP5, or you find an empty slot and you slide in an FP5. You get the capacity without having to re-architect your entire data center. And I think that's the evolution side of things. But within the line card itself, there's massive revolution in terms of design of the chip itself, design of the line card, design of the fabric, There's a lot going on in there. And there's a challenge of delivering more bandwidth, and so what I call the seduction of big numbers, right? You go in there and you think my next chip has to be so much faster, it has to consume less power, and you stop right there because everything else that you want to add to the chip that you would love to have in there breaks the rules of big numbers and lower power. So you compromise somewhere, right? And what we decided is we're not going to compromise. We're addressing a market that is service providers that require the best of the best in terms of quality, performance, delivery of services, security, and to get all of this, you cannot compromise. So when I talk about FP5, we're delivering all of that much better with the same sort of reliability that we have been delivering FP1, 2, 3, and 4, but now at higher capacities with no compromise.
Well, it sounds like there's an awful lot more flexibility for the network operators there. Is it this flexibility that really takes us back to the idea of being able to master the unexpected?
That's a very important aspect of why we build our own silicon. And when we look at something as ancient as an FP3 chip that was, and the systems that we delivered, many years ago, how do you put segment routing on a chip like that when segment routing wasn't even invented back when FP3 came out? The flexibility that we have because we have our own network processor, it's a full processor with instruction sets, and it's not a fixed function ASIC, is that we can, as we humans invent more protocols, more services, we can actually program the FP5 to deliver functionality that we never knew was coming at us. And that's been true with the previous generations of the FP series of processors, and we continue that with FP5. And I think, as long as we're inventing new stuff, we will have to invent chips that are able to meet the flexibility needs of the future. And so it goes with everything that we do, whether it's the hardware, silicon, the systems, or the software.
Okay, absolutely fascinating stuff, Vach. Thanks very much for joining us today and bringing us up to speed on the capabilities and impact of the FP5. Thanks very much.
My pleasure, Ray, and thank you for the opportunity to talk about FP5 and the way we're mastering the unexpected.